recording! Oh, okay. All right, here we go. A set of all points whose difference of distance from two foci what is constant. So basically same definition as yesterday. Yesterday we talked about that the sum is always the same. Now it's the difference is always the same. And after we draw the shape, I'll tell you exactly what that means and it'll make sense. The equations are very similar as well, but there are some notable differences that you have to make sure you get in your brain. If you don't, you'll be lost. X squared over a squared minus y squared over b squared is equal to 1, where a is greater than 0 and b is greater than 0. What's the difference? Minus. So before, with ellipses, true or false, you could switch the x and the y around, and it wouldn't really make any difference because addition's commutative. True. You just switch these around to make a difference? Oh boy. If we go like this, y squared over a squared minus x squared over b squared is equal to 1, a greater than 0, b greater than 0. That definitely changes it, doesn't it? I mean, there the y is positive, whereas the y was negative before. What's the difference? Well, on the first one, the hyperbolas are horizontal, and in the second one, they're vertical. It doesn't matter which is bigger, a or b. With the ellipses, it matters. A is the bigger number, and that's the direction stretched. But for hyperbolas, it doesn't matter which is the bigger number. What matters is which comes first. If x comes first, it's horizontal. If y comes first, it's vertical. I should say if x is positive, and if y is positive, that's what determines it. So the vertices, what we do is here's a horizontal one. So my vertices will be x coordinates. Whereas for this one, my vertices will be y coordinates. So I'm going to go down to my shape. I'm just going to pick an a value, a negative a value. I have a great story to share with you about my daughter Tenley, but we just don't have time today. Nope, not yet. So the transverse axis is the distance between the two vertices. A for the day, who could tell me the distance between these 2 points? 2a. Between those 2 points, 2a. The difference, this is horizontal. This is vertical. Beautiful. Asymptotes. What's an asymptote? A line that it doesn't cross. So this is a sine graph. It doesn't cross that line. Is that really an asymptote? It doesn't cross it, but it approaches it. It approaches it very close. So that's what we want to talk about for an asymptote. So let's talk about our asymptotes. Go away. Okay, so the asymptotes, this is a little bit more involved. I need to generate lines, equations for the lines for the asymptotes. And in order to generate the equations for lines, the book doesn't do this, I do. I make a box. If I go A units horizontal here, do you know how many units I go vertical? B. We'll call it positive B and negative B. And I use that to make a box. Whereas in the other one, I went A units vertical. Any guess on how many units I go horizontal? B, because B is under X. So I go B units horizontal. And I make a box between all those points. And the cool thing is the diagonals of my box are the lines called the asymptotes. So this line right here is the asymptote. So once I make that quick little box, I can then just draw my asymptotes right through the diagonals. Now, in order to write an equation for a line, I need two things. What two things do I need to write an equation for a line? Starts with S, rhymes with lope, slope. I also need a point on the line. In this situation, what very special point do these all go through? 0, 0. Now, that will change when we shift it. It always goes through the center. But for this sake, we could call it 0, 0. That will change when we shift it. So I know it passes through 0, so it has a y-intercept of 0. So now I really just need the slope. Well, look at the first one. If I go from 0, 0, I go up how many units? B, and I go over A. So the slope would be B over A. So M is equal to plus or minus B over A, because you have one line that has that positive slope, and then the other line has that same slope, but it's negative. Look at the other line. How many units do you go up, and then how many units do you go over? Up A over B. So the other one will be plus or minus A over B. And once we have our point on our line, and once we have our slope, we can write an equation for a line, right? Very easy. Any questions on how I got the asymptote information? Okay, then the last part is the foci. And the foci will be, in this case, plus or minus C, 0. And in this case, will be 0 plus or minus C. And the way we get it, we do C squared is equal to A squared plus B squared. So, just Pythagorean theorem. Whoop. So that's pretty nice. And so the foci will sit, they'll actually be larger than the vertices. They'll have a distance greater than that of the vertices from the center. And your graph does not go through the focus points, the foci, it goes through the vertices. And it follows right along with those asymptotes. Does not touch them, but comes very close. You can see that one of these graphs has shapes that go up and down. The other one has shapes that go left and right. And those are what we call hyperbolas. Now, last piece you got to focus on before you try an example. This is the last thing I'll ask you to think very difficult about. If we go back to definition says that a hyperbola is a set of all points whose distances, the difference of them from two foci remains the same. So if I pick a point, say right here, the distance from that focus point subtracted from the distance from that focus point should be exactly the same as if I chose a point, say, right here. Let's say I took this longer distance minus that smaller distance. If you subtract those distances from each other, you should always come up with a constant. And that's what it means. That's how they're actually generated. Somebody said, well, Mr. Gens, how are they generated from cones? And I said, oh, well, that's a really good question. I'm glad you asked. And what happens is you could take a cone and put them end to end. And if you slice them horizontally, can you see how the cross section would give you that shape? Do you see that? A parabola would be if you cut it parallel to the slant. So, but a hyperbola is if you cut it just straight across. That's a hyperbola. Okay, you're bored with that. Let's do something fun. Here we go. All right, let's try this. Sketch a graph of the following. Find vertices, foci, length of transverse axis, and asymptotes. We can do it. First, we start off with this. Where is this thing centered? 0, 0. A, B, and C. I finished that for you. Where did I put it? Do you see it? You're welcome. Okay, so what's A? 2, 5. Square root 29, which is approximately 5.4. So I did a squared plus b squared is c squared. Okay, good. Now, before I actually list those characteristics, which are the vertices, foci, length of transverse axis, asymptotes, I'm going to sketch it because I know I can sketch it. Once I sketch it, then I'll for sure know exactly what those characteristics are. So I'll go up 1, 2, 3, 4, 5. 2, 3, 4, 5. I start by what? Oh, ellipses. Hyperbolas will be the first number. Is this thing going to be a horizontal hyperbola or a vertical one? Length of transverse axis. Horizontal, why? X squared is positive, so it's horizontal. I'm going to make my box. That's the easiest way to get started. How many units do I go in the vertical direction? 5, because 25 is under there. So I go 5 in the vertical direction. 1, 2, 3, 4, 5. How many do I go in the horizontal direction? 2. So I just plot those, and then I just make my box. Sometimes I make dots so fast it confuses the smart board and it just shuts down. I'm really good at making dots. I have a lot of special unknown skills. Tell me they're not unknown. I like to share all my good qualities. Okay. Now I'm going to draw my, what are these things called? Asymptotes. I told somebody they should name their dodgeball team the Asymptotes. Derek Burkhardt. Derek was talking some smack. He says he's going to crush Cody Scherf's team. He has no idea what I said. All right. So, do the vertices go on the top of the box, the bottom of the box, or on the sides of the box? Is this a horizontal or vertical one? Horizontal, so it goes on the sides. Right here. And it just follows along with those asymptotes. It's my graph. Because it's a horizontal one. Hold on. Hannah, then Larissa. Hannah, what? Yes. Yes, the vertices are always, they're 2 units from the center, and our box, we just use it, but they'll always lie right on the box. Right. The box technically is not part of the graph. Only the blue thing is part of the graph. Now, so the blue thing is the graph. So the vertices are plus minus 2, 0. What's the length of the transverse axis? We'll get to see in a second. Larissa, you asked how do we know it's horizontal? Because x squared is positive. If it was a y squared first and minus an x squared, then it would be vertical. Then we put them on top of the box and bottom of the box. Okay, so now we need C. So Bennett's question, what do we use C for? C is for the focus points. So the focus points are how many units away from the center? Like almost 5.5, whatever C came out to be, 5.4. And they always lie in the direction that it goes. So it goes horizontal. 1, 2, 3, 4, 5 point whatever. 1, 2, 3, 4, 5 point whatever. Those are my focus points. All right, F for focus. And those coordinates would be plus or minus square root of 29, 0. Right? So now I just need the equations for the asymptotes. And the asymptotes are lines, so they need to have the form of y equals mx plus b. As you look at this graph, what is the y-intercept of the asymptotes? 0. So we just need an m. Y equals. Look at your box. How many did you go up? 5. How many did you go over? 2. So that's the equation of my asymptotes. Kind of cool. There's at least 2 questions in this group that people are not asking. What are they? Danny. If A was 3, then the box would be stretched out 3 units as well. And it would, the point, the vertice would lie right on the edge of the box. Jensen. Length of the transverse axis is the distance from here to here. Twice the A value. Hannah. So if I took the line y equals x and I graphed it, that would look like that, right? If I said y equals 3x, well, that would be even greater, right? So those are lines that have a y-intercept of 0. 5 over 2 is the slope. We figured that out by going up and over. We have one line that has a positive slope, and the other line has a negative slope. That's why we wrote plus or minus. The 5 over 2 represents the slope, yes. But this is an equation for a line. We can put that right in our calculator and graph it, and that will give us a nice looking 2 lines. Will they be curved? Yeah, it's just these 2 diagonal lines. No. In order to get the blue, we would have to solve this equation for y, and we would get 2 solutions. We'd have to graph both of those. The blue one is the actual graph. Everything else is just imaginary stuff that we use in order to graph. Yep, the only actual graph is the blue stuff. If we plug in our calculator, that's all we get. Any other questions? Going once. What up, dog? A box of Kevin's? After I smack you around on the basketball court and teach you a lesson or two. I'll dunk all over you after school. You wait. That's it. We're going to have a new type of math class. We're going to have Survivor math class. And at the end of every week, somebody's going to get voted off. We'll see how long you last, Skywalker. All right. Okay, next one's going to go quick because now you guys know how to do it. Only this one is not solved equal to 1. What do I do? Divide by 36. You are so smart. Super smart. X squared over 9er minus y squared over 4 equals 1. What? 9er. That's from a great movie called Tommy Boy. Obviously, you've never seen it. Possibly the most hilarious movie ever made. You watched the driver's ed class? Here's what you do if a deer crawls in the back of your vehicle. Are you serious? There's so many great driving lessons in that movie. Like you should have a door on your car if you're going to drive. Do not stick dead vermin or deer in the back of your vehicle. There's all sorts of great lessons to be learned. What's the center? 0, 0. What's A? 3. What's B? C. Square root of 13. Square root of 13 is like what? 3.7? We're just guessing. We just make up numbers. Okay. So then we'll list the vertices. We'll list the foci, length of transverse axis, and the asymptotes. There we go. I don't really know what those are, so I'm going to actually graph it and then look at my graph to determine those things. I do know how to graph it because I provided myself easy steps to graphing. The first thing I do is I make a box. How high is my box? 2, because the 4 is under the y. How long is the box? 3. So I go up 2. I go over 3. I make my box. That's my box. Since I just made my box, I'm going to make my asymptotes too, because that's why I make my box. You know why I started doing that? Because I took this class on my own with no teacher. And I couldn't find a very good way to graph these things and keep everything straight. So I said, I'm just making a box. I'm going to do this on my own. And that's what I did. And I think it helps. So there you go. Mr. Gentz's box method. So, all right. So the vertices, do they go on the top of the box or sides of the box? Why? Because x squared is positive. It's the first one, so it goes on the side of the box right here. Do I now have enough information to actually draw the graph? I sure can. So you can see this one is much sharper, more narrow. The other one was very wide. Okay. Technically, you're not supposed to touch it. If you do, do not pass go. Do not collect $200. Get your finger cut off by Miss Nelson. But there are important parts that we have not characterized yet. First, let's just list the vertices, though. What are they? Plus or minus 3, 0. What's the length of the transverse axis, the distance between the two 6? The foci are simply, they're technically used in order to generate the graph. We didn't have to do it because we're smarter than that. But if you do a squared plus b squared, you get 13, right? So, it's just short of 4. So you just put your focus points right there. And those would be, we said, plus or minus the square root of 13 and 0. If you can reduce the square root, you should do that. But 13 doesn't reduce. And now we have the wonderful asymptotes. And the asymptotes, again, need to be in the form of y equals mx plus b. And you're asking yourself, Mr. Gens, why do you keep on writing y equals mx plus b if we don't have a y-intercept? Because sometime you will. Because tomorrow we're going to shift this over 2 units and down 3. And that changes everything. And that's okay. And so we're going to have a y-intercept different from 0. But because we just have 0, all we need to come up with is a slope. What is the slope? How many up and how many over? 2/3. So we have y equals plus or minus 2/3 x. How many lines does this account for? 2. And some people got confused with that last year. You can't go like this either, people. Y equals negative 2/3. That's a horizontal line. That's 2 horizontal lines. That's a line that has a slope that looks like the asymptotes that I have. So that's what we got. Any questions? A lot of information, right? But if you go through the process, not too bad. Riz. They are both horizontal because they head off in the horizontal direction. Here's what they would look like if they were vertical. If they were vertical, I'd draw it with the blue. So if we made this one change to the equation, if instead of x squared over 9 minus y squared over 4, if it was y squared over 4 minus x squared over 9, then we would get the blue one. That's it. That's the only change. What? In order to get the blue, the y squared would have to be first. What? Exactly. Negative y squared, x squared over whatever, 4 plus y squared over 9. Now that's vertical because the y squared is positive. It's whatever's positive. Yep. That's just not written in the same form. You guys got it. You're super smart. You're math geniuses, which is why you deserve an assignment to extend your learning. 9.3, 751, numbers 1 through 6, and 9 through 11.